reduction gearbox is used in various applications. So we'll discuss which are those applications. First, a gearbox is to be designed for lifting or hoisting application with the following specifications. Okay, number of persons to be lifted. So you will be given how many persons the lift has to lift. Maybe 7 persons, 10 persons, 6 persons. Okay, that number of persons will be given. Rope drum diameter. Now we'll see later on what is rope drum and where it is used. Okay, rope drum is the part through over which rope passes, and at the end of the rope the lift is attached. I will draw later on figure. Then lifting speed, the speed which at which lift is to be lifted. That speed is given as 1.25 meter per second to maximum 1.5 meter per second. That means you have to design it in such a way that the speed remains in between these two values. Okay. Total speed reduction, that means gearbox input speed and output speed. The total reduction has to be 12. That is also input given. Select suitable prime mover for this application. Prime mover means motor. You can take motor as a prime mover. Engine is also prime mover. IC engine is also prime mover. Okay, but here we use motor. So select suitable prime mover for this application and assume suitable data wherever required. We know in design subjects we assume many things, but that assumption is with respect to certain guidelines. Okay. Then select suitable materials for various components. For design purpose, we need to select suitable materials. Draw detailed drawing and assembly drawing. This is the last part of the project. We have to draw detailed drawing, assembly drawing, and mention which dimensional geometric tolerances and surface finish symbols on the drawing. Okay, so drawing has to be manufacturing drawing. Drawing should not be only drawing something. Okay, it should include all these. The tolerance values, geometric tolerance, dimensional tolerance, and surface finish symbols. Okay, so by all these activities will comprise our project. This is a motor. Okay, so motor drives these two drums. Can you see? These are the drums. So this is one drum, this is another drum. Over the drum a rope passes, and at the end of the rope there is a hook. So hook is used if it is crane application. Okay, if it is crane, then we have to use hook. But in case of lift, that rope will be tied securely to the cabin. You understand cabin? The thing where we sit inside, and then that particular cabin goes up and down. Okay, so at the end of the rope, cabin or that particular part is attached. Okay, then you can see here, this is kind of gearbox. Motor here. Can you identify there is a small gear here? Can you identify that? Okay, so there is a small gear here. In contact with small gear, there is a large gear. Okay, so when a small gear engages with large gear, we achieve speed reduction. And when large gear engages with small gear, we achieve speed increase. Okay, so here small gear engages with large gear. So due to this, there will be speed reduction. Okay, so motor will rotate at certain speed, and that speed will be reduced in the first stage. Okay, this is called as stage. In the first stage, there will be speed reduction. Now on the same gear shaft, you can see there is another small gear mounted. Are you understanding or not? On the same gear shaft, what I am saying, on the same shaft, this one gear is mounted, and at the same time there is another smaller gear mounted. Okay, so this smaller gear again engages with larger gear. So in the second stage there will be further reduction. I hope you are understanding what I am saying. In the first stage there is certain value reduction. In the second stage again there will be reduction. Okay. Now on the same shaft, you can see there is another smaller gear mounted, and in contact with that there is a larger gear. So you again get certain reduction. So this is 3-stage reduction. How many stages here? 3 stages. Here first stage, here second stage, and here third stage. And on the last gear, you can see there is a rope drum, and over this drum, rope will pass, and at the end of the rope there will be whatever required. Like if it is crane application, there hook will be attached, or if it is a hoisting application, then cabin will be attached. These are another similar applications. This smaller gear, larger gear, then again larger gear, and then there is a rope drum. So whenever you want to have reduction, you have to engage smaller gear with larger gear. Crane application, you might have seen such cranes. They are called as EOT cranes. EOT cranes. Okay. So in EOT cranes also we need to have reduction gearbox. Why I am showing this application? Because in EOT cranes also we need to have reduction gearbox. Okay, and that gearbox is here. It is situated somewhere inside in this. Okay, and then at the end of this there is a, what is this? Hook. And then hook will be used for lifting load, weights. Okay, same application. Just to show that these yellow parts, they are called as girders. Specific name to that is, what is that? They are called as girders. Okay, so such two girders are there, and on top of the girder there is a trolley. So this part travels like this, and trolley travels like this. So you can literally pick up any object within that particular space. Okay, so girder and then trolley. Again in this case there is a motor, then inside this gearbox, and at the end there is a hook. This picture also gives a clear idea of reduction gearbox. Okay, you can see, of course this is only for pulley. There is a pulley block, there is, here is the gearbox, you can see here. Motor, then one gear engaged with other gear, again this gear engaged with this gear. So if this is smaller, this is larger, you will get speed reduction. Then here also, motor, coupling, rope drum. Now in this case, there will be gearbox inside this cabinet only. Along with motor there will be gearbox. So that is coupled with the rope drum with the help of coupling, and then at the end of the rope there is a load. This is also another reduction gearbox. You can see here. I hope you can easily understand. How many shafts are there? 3 shafts. One shaft, second shaft, third shaft. Okay. On the first shaft, you can see there is a smaller gear, and in contact with that, there is a larger gear. So what will you get? Speed reduction. Now on the same shaft, there is another smaller gear, which is meshed with larger gear. So from here to here, there will be further speed reduction. Okay. As far as diameters are concerned, what is the relation from input to output? Input shaft diameter is smaller. Output shaft diameter is larger. Why is it so? Torque. Be specific. What do you mean to say? Higher torque. Speed is going to reduce. Speed is going to reduce. Torque is going to increase. Because the relation power is equal to torque into omega. This relation, you know, power is equal to torque into omega. Power remains same because we are supplying constant power from the motor. Okay, so if speed reduces, omega is nothing but 2 pi n upon 60. So if n reduces, torque increases. And to handle that higher torque, you need to have larger shaft diameter, because there is again one more relation. Torque is equal to pi by 16 tau dq. That means diameter of the shaft is directly proportional to torque. Is it clear? So higher the torque, larger the diameter of the shaft. Okay, that's why you find, and in our design also you will understand that as we go to the output shaft, diameter of the shaft will go on increasing. Okay. This is another gearbox. You can see this is the casing part. It is bolted at the top, something like this. That means the casing is like this, horizontally two halves, one half and second half. But sometimes the casing may be something like this: lower half, upper half, or lower casing, upper casing. In this case, it is say casing on the left, casing on the right, and they are bolted together. Okay. This is one more reduction gear box or gear unit, you can say. How is it? First stage 1, spur gears. Okay, so these two are the spur gears. So from where power transmission will start? From the smaller gear. Okay, so motor will be connected to this shaft, right? Motor will be connected to this shaft. This gear will be meshed with this gear. So speed will reduce. Now on the same shaft, what is this? Worm. Okay, worm and worm wheel. They are used for large speed reductions. Worm and worm wheels are used for large speed reduction. Okay, when we study the unit, that time we will understand the ratio for worm and worm wheel is much higher than that of spur and helical gears. Okay, so this worm is in contact with this worm wheel. Worm and counterpart is worm wheel. Okay, so worm axis is like this, worm wheel axis is like this. So worm and worm wheel, last time I told, are used to transmit power between two perpendicular shafts but non-intersecting. Two perpendicular but non-intersecting shafts like this. Okay, so then power is transmitted to this worm wheel. Now you can see this particular, on this shaft there is another worm. What is that worm? 2, second worm. So if you want to have further reduction, you can again achieve it with the help of second worm pair. Okay, so through this worm wheel, and finally you get output at the output shaft. Okay, so how many stages in this case? First stage, second stage, third stage. So there it is again 3-stage speed reduction gearbox. Okay, and this is the example of a gearbox casing. Okay, you can say lower half and this is upper half, and then it is enclosed. Okay, such applications also used in hoisting or lifting applications. Okay, rope drum 1, rope drum 2. There are motors. So motors along with the speed reduction units ultimately drive these rope drums, and rope drums lift the load.